Changing views of distant objects have been captured by various observers over the years. And these effects we witness across these small bodies of water seem to mirror what is observed over greater distances, presented by channels like BMLSB, Wide Awake, The Plain Truth, and many other observers in this realm of research, some of which are linked in the description below. Next, we'll show some observations from our land in the Colorado mountains. The surface we are viewing across is not perfectly smooth and definitely has some undulation to it, but during the evening and morning hours, while the air and surface temperatures are mostly evened out, we're able to see distant objects in full. During the day, however, the air layer at the surface will pretty much always be warmer than the air above it, and the temperature will decrease with gain in elevation from there. And so, sinking refraction occurs. In this observation, the cars are placed 45, 60, and 75 feet from the viewer, and we're viewing from about half an inch above the surface. This evening, the light from each of the cars arrives to the viewer in full. During the day, however, the objects appear to sink into the surface, with the most distant car sinking the most. We have to raise our viewing height to receive the light from the cars in full. Here is a test with a small amount of obstruction caused by the undulation of the surface. Even around sunset, when the air temperatures are evened out, we have to raise our viewing height to see the objects in full, as they are being blocked by the physical surface. During the day, the objects appear to sink as the obstruction of the surface is exaggerated. Only the very top of the yellow car is now visible, and we have to raise our viewing height more than the previous evening to receive the light from the distant cars in full. Next, we'll look at some scaled observations of a distant highway and house. Daytime temperature highs reached the 40s and 50s in these observations. The highway and house we're viewing are 1.8 and 1.9 miles away, respectively, and we're viewing from just under 6 feet. In order to closely scale this, we'll imagine a scale of 1 inch equal to 10 feet, putting our small-scale representative objects at around the same relative distance to the viewer height. On the large scale, during the evening, cars can be seen in full for the most part. But during the day, only the very top of the cars are visible. The same effect occurs on a small scale. This evening, the Hot Wheels car is seen in full, but during the day, only the top is visible. Here is a semi-truck one evening, and a semi-truck during the day, and another small car during the evening, and during the day. Last, we'll look at some observations conducted from home, both in a garage and from a living room floor. At distances of 35 feet and less, these tests are conducted at an even shorter distance than the previous observations. So, they require a difference of temperature from the indoor and outdoor environments of around 30 degrees Fahrenheit or more in order to witness noticeable results. You can create both increasing and decreasing temperature gradients by keeping the surface warm and cooling the air above, or vice versa. Each will present varying results. Here, we placed a few earrings and small rocks about 35 feet away from our viewer, which has a viewing height of about 1 inch above the surface. The indoor environment temperature was around the 70s in degrees Fahrenheit, and the outdoor environment was in the 30s. As we open the garage door a bit and let cold air in near the surface, the objects appear to sink into the surface, which also appears to drop. Here we speed up the footage. and here we close the garage door. As the air in the room evens out, the light from the objects arrives to the viewer in full. Here is an observation from a living room floor. Notice the reflection of light on the surface. When we open the patio door, the same sinking effect occurs as the reflection and the bottom of the objects are no longer visible. The reflection then comes back into view when the door is closed. Here's an observation where we placed 3 small buttons at 14, 16, and 18 feet from the viewer. As we open the patio door, the buttons appear to sink, with the most distant button appearing to sink the most and the nearest button appearing to sink the least. Also, the original horizon, which was caused by the floor meeting the far wall, now appears closer, therefore lower in the field of view to the observer than it was at the beginning of the test. All of these tests and observations show us that there may be an alternative explanation for bottom-up disappearance of distant objects. Many people attribute this disappearance to curvature of the Earth, but we've seen in these various observations that the surrounding air is capable of making flat or level surfaces appear convex by displacing the light from distant objects and making them appear to sink.